I'm Anil Kumar, sharing with you some excellent questions from previous test papers. You can pause the video, copy them. You'll find solutions for all these questions in my videos. Now we will discuss question number 2, part C. Here is the question, which is based on limits. So that is the question which we are going to discuss now in details. So the question for us is, we are discussing limits of indeterminate quotients. The question is to evaluate limit when x approaches 4 for x square minus 5x plus 4 divided by square root of 2x plus 1 minus 3. Now in this, if I substitute 4 for x, what do I get? Let us check this out. So we get 4 square minus 5 times 4 plus 4 divided by square root of 2 times 4 plus 1 minus 3. Now the numerator, 4 square is 16 plus 4 is 20 and 5 times 4 is 20, so we get 0, 20 minus 20. And in the denominator, 2 times 4 is 8, 8 plus 1 9, square root of 9 is 3, 3 minus 3 is 0. So whenever you get 0 over 0, we call it indeterminate quotient, right? That is what we mean. Now in this situation, you could apply different strategies to solve. One of them is rationalization. Now rationalization is used whenever you have square root. So if square root is there, that is the preferred method. So let's solve this using rationalization. So we have limit x approaches 4, x square minus 5x plus 4 divided by square root of 2x plus 1 minus 3. Now to rationalize, we will multiply and divide by conjugate of this denominator. We are rationalizing the denominator, right? So we have square root of 2x plus 1 plus 3. That is what you multiply and divide by. Now once you do that, what do you get? You get limit x approaches 4. As far as the numerator is concerned, we'll keep this part as such, but we can factor the quadratic part. Remember, quadratic part was 0 for x equals to 4. That means 4 is a factor, right? Now we are looking for two numbers whose multiplication when you product is 4 and sum is minus 5. So the numbers are minus 4 and minus 1, right? So you could write this as x minus 4 times x minus 1. When you expand, you will get x square minus 5x plus 4, right? Times, let me write this in brackets, 2x plus 1 plus 3. As far as denominator is concerned, a minus b times a plus b, a square minus b square. Square of square root will be 2x plus 1, in this case minus 9, correct? So that is what you get after rationalization. So you get rid of the radical part, in this case from the denominator, since we rationalized denominator. Now we can simplify this expression. We have x minus 4 times x minus 1 times square root of 2x plus 1 plus 3 divided by, so we can open the bracket and solve it. So we get 2x plus 2 minus 9. So that is 2x plus 2 minus 9 is minus 7. Sorry, this is 2x plus 1. I wrote plus 2, 2x plus 1. So when I do plus 1 minus 9, I get minus 8, right? So we get minus 8. So we have now limit x approaches 4, and the numerator, it is x minus 4 times x minus 1 within bracket 2x plus 1 plus 3, and here we can factor 2, right? So when you factor 2, you get x minus 4. Now x minus 4 could be cancelled. That's a common factor in numerator and denominator. Once you cancel that, after that you can substitute 4 to find the answer. So we get 4 minus 1 So we are substituting 4 now after cancelling within square root. 2 times 4 plus 1 plus 3 divided by 2. That gives you 4 minus 1 is 3, and within bracket you get 8 plus 1 square root is 3. 9 square root, right? Plus 3 divided by 2. So that is 3 plus 3 is 6, and 6 times 3 is 18, right? So we get 18 over 2, or 9 as our solution, right? So 9 is the limit for the given function as x approaches 4. So we can write this as 9 as our answer, right? So that is how it should be solved. Let us go through these steps once again. So whenever you have 0 over 0, it's an indeterminate quotient. You can apply different methods. But since we have square root, we rationalize, in this case, denominator. Rationalization means to multiply and divide by the conjugate, right? So conjugate of square root of 2x plus 1 minus 3 is 2x plus 1 plus 3. So we multiply and divide by those terms and then simplify to get the answer. I hope that helps. Thank you and all the best.